First off, what is trigonometry? What is trigonometry? As opposed to geometry, algebra. What? Mm-mm. Remember, the trigonometry was built around a long time ago. We didn't talk about trends back then. Trigonometry deals with figuring out we have a circle, or actually, it doesn't have to be a circle. It could be anything. There's a big old tree, and you're standing. Let's say you're standing 20 feet away from it. At the tip of its shadow, trigonometry deals with angles to measure distances. What are angles? Angles are the distance two lines have from each other from a horizontal plane. So we use theta as typical angle. The same thing works in circles, which is what we're going to define all these with. In other words, if I had a compass, a little thing that looks like this, and I have here 0, I have here 90 degrees, and I have here 180 degrees. If I could put that down here and determine what this angle is, I can tell you exactly how tall this tree is. Just knowing how far I am from the tree, there's the length of the shadow and the angle from which the top of the tree is staying. And this is all going to be done by trigonometry. There are 6 trig functions, which we're going to define here. And they're all based on the unit circle. And the Pythagorean theorem. What is the Pythagorean theorem? Right. In algebra, we first discuss lines, straight lines. And then from there, straight lines are then, we go into define slopes and midpoints and distances. For example, if I had a point at 0, 0, and another at 3, 4, how far are these points away from each other? What is the distance between point A and point B? Right. We can use the Pythagorean theorem to figure that out. Because horizontally and vertically, the Pythagorean theorem, A is the base, B is the height, C is the hypotenuse. The distance from this point to that point. So A is the horizontal distance, that's 3 units. It goes up 4 units. This is B. I can figure out what C is by using this formula. 3 squared plus 4 squared equals C squared. 25 equals c squared, square root both sides. C is 5. From that moment, we can now define a circle. How is a circle defined? An infinite number of points that are all equidistant from a central point, from a central location. All of these points on this circle are all the same distance from that center point. And all those, the distance, are all calculated by Pythagorean theorem. This is A, that's B. This is A, that's B. The distance now has another name. The distance from the center point to the point on the circle is called the radius. Now, if all those are the same, now we have a circle. Well, we say if the radius is 1 unit long, that means our circle goes from 1, 0, 0, 1, negative 1, 0, 0, negative 1. Everything in trigonometry now starts off with this. And we're going to use Pythagorean theorem to find values along the line, along this curve. So the 6 trig functions that we're going to be dealing with are the sine of an angle, cosine of an angle, tangent. This is called the cosecant. The secant and the cotangent. These are what we call reciprocal functions or reciprocal angles. In other words, cosecant is the same thing as 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. So they're reciprocal of them. That's fine and dandy. We have to first see what sine, cosine, and tangent are. In our unit circle, remember this is at 0, 1, 1, 0, negative 1, 0, 0, negative 1. We have the horizontal axis and we have the vertical axis. Each point corresponds to an x and y component. At some angle. To determine the x component, in other words, where this point now reflects down the x-axis, if it deals with the x-axis, that's the cosine of the angle, the cosine value. The location on the y-axis is the sine component. So each point xy corresponds to some cosine of some angle and sine at that same angle. So far, so good. What does tangent mean? If we define the word tangent, what does that mean? How do you mean? That's adjacent or parallel. So what would be, at this point here, what would something tangent to it be? Yeah, it forms a 90-degree angle to the radius, and it just touches that curve at one point. That's tangent at that angle. So since it's a point, it's got to deal with the x and y components. Or the y over x. So since we know that sine deals with the values of y, cosine deals with the values of x, tangent is sine over cosine. That means it deals with y over x. So what's cosecant going to be? 1 over y, 1 over x, 1 over y over x, which is x over y. Remember, these are reciprocals. This is y over 1. So when I reciprocate it, it becomes 1 over y. This is x over 1. When I reciprocate it, it becomes 1 over x. Y over x becomes x over y. Let me see some pictures here. Oh. So using our unit circle, let's look what these values are. The sine at 0 degrees. That equals the value of y, right? What is the value of y at 0 degrees? That's where the circle meets this x-axis. What's the y value there? The y value is 0. So sine of 0 is 0. What's cosine at 0 degrees? In other words, at 0 degrees, this is the horizontal. It's 1. It starts off here. This is the pretty much, okay, everybody says this origin, but in the unit circle, this is where it begins. In trigonometry, the angles go counterclockwise. It goes from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. Again, when we talked about the algebra part of this, it's because that's the motion of the sun. Starts in the east and goes to the west. Now, at a right angle, when this is, what degree is that box right there? It's 90 degrees. So at 90 degrees, what is the sine value at 90 degrees? 1, because that's the y value. What's the cosine of 90 degrees? Yeah, it's the x value. Remember, cosine deals with y, sine deals with y, cosine deals with x, the x component of that graph. So from the horizontal line to straight up is 90 degrees. So if we go 90 degrees more, we're now at 180 degrees. So the sine at 180 degrees is what? What's the y value at 180? 0. What's the cosine of 180? -1. Very good. And we continue even further. If we add 90 degrees more, we get to 270 degrees. So the sine at 270 degrees, what's the y value at that point? -1. The cosine at 270 degrees is 0. To complete the circle, we add 90 degrees more, we get 360 degrees. So the sine at 360 degrees is what? Is 0. The cosine at 360 degrees is 1. Because at 0 degrees and 360 degrees, it's the same thing. How about if I gave you the sine at 450 degrees? What would that be? Why would it be 1? Well, let's see. Because we know that 360 degrees is all the way around. So we subtract 360 degrees. We get 90. So the difference is 90 degrees. So the sine of 90 is 1. Those are positive angles. What if I give you a negative angle? Cosine of -270 degrees. Negative means I go clockwise. This is -90. This is -180. This is -270. So what's the location there? So what's the cosine of that point? 0. Remember, cosine, all our points are x and y, which are the same thing as cosine sine. Those are degrees. We have another type of measurements called the radians. Radians have to do with respect to pi. The radian measures. So for example, again, this is 0. We've heard, how far is it around an entire circle? How many pi? So this is the same thing as 2 pi. It's also the same as 0. So halfway through that would be what? So from 0 So this is the same thing as 180 degrees. Or the same thing as 360 degrees. So what would straight up and down be? If this is pi, what's this one going to be? Yep, it's half of pi, which is 90 degrees. So that's 1 pi over 2, 2 pi over 2. This one is 3 pi over 2, which is 270 degrees. So the cosine of negative pi would be what? Negative 1, right? Because start here, you go here, pi is 180 degrees. The location here is negative 1, 0. Those are more examples. That one, we did those already. We could talk about those. Let's see. Especially these are pretty boring. We'll talk about that in a second. Right. So these are the major points. What about some other ones? At 30 degrees. Or if we cut that in half at 45 degrees. Or at 60 degrees. What are the location points there? The values. Yeah, I mean, you probably have the charts and you have see it all, but that's not important. It is important is how do you, if you didn't have those pieces of paper there in front of you, how would you find them? Yeah, don't get too dependent on those. First, learn how to derive them because all you're doing there is regurgitating. You're not deriving anything. So, with that, I wouldn't put too much credit to them. So, to find these values here, again, we start with the right triangle. This is 90 degrees. Let's say up here was 30 degrees. What's this one going to be? 60. All right, so we'll call this one A. We'll call this B. What's that length going to be? Well, it's going to be C, but what's going to equal? Always. That's all. That's only thing we talk about in trigonometry. Why would it be 2A?
Well, isn't that what relationship of the vertices?
Be radius of what? Yes, the radius. Yeah. You were close. So I see how you got that 2A part, but we'll get to that one in a minute. That deals when we deal with the 60-degree part. So here we can look at two different angles. SOHCAHTOA. SOHCAHTOA. It sounds like an Indian word, but it's not. What it means is the sine function, the sine of some angle, equals the opposite over the hypotenuse. The cosine function equals the adjacent over the hypotenuse. And the tangent of some angle is the opposite over the adjacent. Now, what this refers to, whatever angle we have, this part, the opposite of the 90 degrees, that's always the hypotenuse. The side touching that angle is the adjacent. The side not touching the angle is the opposite. So this is pretty important. This is where a lot of confusion occurs, is people get confused about what's adjacent. Adjacent simply means it's touching. It's part of that angle. The opposite doesn't have anything to do with it.
Those references change.
Yes. So for example, here, the cosine of this angle would be the adjacent over hypotenuse. The sine of this angle would be the opposite over hypotenuse. But let's say we had that angle there. With this angle here, this is now the adjacent. This is the opposite side, depending on where the angle is. And this is always the hypotenuse. So it's relative, yeah, to where the angle is. So if we had all three sides were equal to 1, what would A be here? Now we can figure out what the height is going to be. What's B going to be? Because we're looking at, in this case, it's 60 degrees. So what's the value of B? How do we find it? We have A squared plus B squared equals C squared. Pythagorean theorem. Whenever you deal with right triangles, you always deal with Pythagorean theorem. So our A is 1/2. B, we don't know yet. C is 1. Let's solve for B. So we get 1/4 plus B squared equals 1. B squared equals 1 minus 1/4. What is 1 minus 1/4? Because this is 4/4 minus 1/4 is 3/4. Square root both sides, which is becomes square root of 3/2. So that's what this one equals. So no, at 60 degrees, once we know what these sides are, we can do the trigonometric identities at 60 degrees. So find the sine and cosine of 60 degrees. So yeah, we have this. A equals 1/2. B equals square root of 3/2. And C equals 1. And this is 60 degrees. So what would the sine of 60 degrees be? No. What is sine? Think of, so the opposite, which is square root of 3/2, divided by the hypotenuse, which is square root of 3/2. What's the cosine of 60 degrees? Adjacent over hypotenuse. The adjacent is 1/2 over 1, which is 1/2. We can do the same thing now for 30 degrees. So the sine of 30 degrees is what? Yeah, it's opposite over hypotenuse, which is 1/2. And cosine of 30 So let's build our chart. So we have the angle, we have 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So we have sine of the angle, cosine of the angle, tangent of the angle, cosecant of the angle, secant, and tangent of the angle. Let me see. Where's the next example? Oh, well, we'll make up our own. So what is sine of 0? Cosine of 0? What's tangent of 0? Remember, tangent is sine over cosine. 0/1 is 0. Cosecant. Cosecant is 1/sine. Why is cosecant 1/sine and secant 1/cosine? How can you remember that? The way I remember it is you cannot have the first letters. Secant, the sine starts with S. I can't use secant because that's 1/cosine. I gotta use cosecant. Cosine and secant. So it has to be opposite first letters. So cosecant is 1/sine, which is 1/0, which is undefined. Secant is 1/cosine, 1/1, which is 1. tangent, this is cotangent, which is cosine over sine, or 1 over tangent. So we have 1 over 0, which is undefined. We can also do the 90-degree ones. So the sine at 90 degrees, cosine. So you notice how sine and cosine at 0 and 90 degrees, they flip. The same thing is going to happen throughout the whole thing. The sine of 30 degrees is going to be the cosine of 60. Cosine of 30 is sine of 60. They're going to be opposites of each other. So the tangent at 90 degrees, sine over cosine is undefined. Cosecant of 90 degrees is 1 over 1, which is 1. Secant is 1 over cosine, which is 1 over 0, which is undefined. And cotangent, which is cosine over sine, which is 0 over 1, which is 0. So let's put our 30 and 60-degree angles in there. We just did. Sine at 60 degrees is square root of 3 over 2. Cosine at 60 degrees is 1/2. And again, it says they're opposites. So sine at 30 is going to be 1/2. Cosine at 30 is going to be square root of 3 over 2. What's tangent going to be of 30 degrees? Right, it's going to be 1 over 2 divided by square root of 3 over 2. 1 over 2 times 2 over square root of 3. The 2's cancel. 1 over square root of 3. Remember, you cannot have a square root on the bottom. So 1 over radical 3, we have to rationalize it. Becomes square root of 3 over 3. Square root of 3 over 3. Cosecant at 30 degrees. So 1 over sine, 1 over 1/2 is 2. Because you flip the bottom. Secant of 30 degrees. So it's going to be 2, it's 1 over cosine. So we flip that. So it's 2 over radical 3. Rationalize the denominator. So we get 2 radical 3 over 3. And the cotangent at 30 degrees is 1 over tangent. So we got to flip the tangent. So we got 3 over radical 3. Rationalize the denominator. 3 radical 3 over 3, which makes it just radical 3. Let's do 60 degrees now, the same way. Tangent at 60. Sine over cosine, so it's radical 3 over 2 divided by 1/2. Flip them, we get radical 3. Remember, at 30 and 60, tangent and cotangent are going to swap numbers. So we know the cotangent at 60 degrees is going to be radical 3 over 3. Cosecant at 30 is the same thing as secant at 60. Secant at 30 is the same thing as cosecant at 60. Any more examples here? Oh, don't want to do that one. Well, now the question becomes, what happens at 45 degrees? Because we started off with a 30, 60 degree angle. That's pretty easy there. What happens at a 45 degree angle? If that's 45 degrees, what do we know up here? It's also going to be 45. So how are we going to do this? How are we going to prove the 45 degree angle? That, yes. Why are they equal? Because if A is here adjacent to 45, well, this is also, so at 45, A equals B. Very good. So now what's that going to give us? A squared plus A squared equals C squared, or A squared plus B squared equals C squared. So we have 2A squared equals C squared. We have square root of 2, square root of A squared equals C. So square root of 2A equals C. So A is equal to C over square root of 2. And C is what? 1. So we have to rationalize it. Square root of 2 over 2. So for the sine, so the sine at 45 degree angles is square root of 2 over 2. The cosine is square root of 2 over 2. Because they're both equal at that point. A equals B. which means tangent is 1, which means cotangent is 1. What are cosecant and secant going to be? Yeah, so we reciprocate it, so we have 2 over square root of 2. 2 radical 2 over 2, so it equals square root of 2. Okay, that's why I, instead of using this chart, pre-made charts, understand where it all comes from. Because now, once we have this defined, we have the entire unit circle defined.
One.
No. Of course, yeah, we do that at any time. We just did that. We just converted from. So we have this location, which is 1, 0. At 30 degrees, what's the x value?
No.
At 30 degrees, remember, cosine is at 30 degrees, is the x value. So it's radical 3 over 2. And the y value is 1/2. At 45 degrees, they're both radical 2 over 2s. At 60 degrees, we have 1/2 radical 3 over 2. Notice how they switch sides. And then here we have 0, 1. There is a pattern forming here. On the x values from 0 degrees, it starts off at 1. Then it goes to radical 3 over 2, radical 2 over 2, radical 1 over 2, and 0 over 2. On the y values, 1/2, which is radical 1 over 1, radical 1 over 2, radical 2 over 2, radical 3 over 2, and radical 4 over 2. Radical 4 over 2 is 2 over 2, which is 1. So it just changes directions both ways. Now, with these, we can figure out the quadrant 2 information. This one's going to be what? The x value changes. The y stays alone. In this one, the x value changes. So this is minus 30 degrees from the straight up. So if I add 30 degrees, from 90 degrees plus 30, this is 120 degrees. This is 30 degrees off of the horizontal. So this is 180. If I subtract 30 from it, I get 150. '90 plus 45 is 135. So this is 60 degrees. This is 45 degrees. This is 30 degrees, this is 0 degrees. And we can go on further from there. The next three. 30 degrees from 180 is 210 degrees. Here, they're both negative. (180 plus 45 is 225). Again, at here, at the 45, they're both negative. And this is 270 minus 30 is 240. And that one's going to be, they're both negative again. See, the only thing it does is change the signs because of their locations. And the next three. This is 360 degrees. So if I subtract 360 degrees, I got 330 degrees. The X is positive. The Y is negative. Because I subtracted 30. Because in quadrant 4, only the Y values are negative. In quadrant 4, we have positive, negative. So 360 minus 45 is 315. So it's the same as the 45. So it's radical 2 over 2, negative radical 2 over 2. Only thing changes the signs. 270 plus 30 is 300, which makes it 1/2 negative radical 3 over 2. So do you have to memorize all of these numbers? No, you just have to memorize the first quadrant. And then 30 degrees off the x-axis. In the second quadrant, only the x is negative. In the third quadrant, they're both negative. In the fourth quadrant, only the first one's negative. The y value is negative. So all you have to do if you want to memorize it is not even that, is memorize 30 and 60 because 45 is the same thing. So it just takes all the memorization that students get freaked out about when I teach trig courses. They say, I can memorize that. No, all you gotta do is memorize 30 and 60 because then the unit circle tells you the rest. Let's look at this in reference to pi. 30 degrees is what with respect to pi? This one is -1, 0. This is 0, -1. So 30 degrees is 180 divided by 6. So 180 divided by 6 is 30. So, which is pi over 6. That's what 30 degrees is. (45 degrees is 180 divided by 4. So it's pi over 4. (60 degrees is 180 divided by 3. So it's pi over 3. (90 degrees is 180 divided by 2. So it's pi over 2. (120 degrees, we have 1 pi over 3, 2 pi over 3. So this is 2 pi, or 2 pi over 3. at 135. 1 pi over 4, 2 pi over 4, 3 pi over 4. This is 1 pi over 6, 2, 3, 4, 5, 6, 7. No. 1. So this is pi. And since I'm going backwards, is 5 pi over 6. Because I have pi and I subtract 30 degrees, which is pi over 6. (210 degrees), 5 pi over 6, 6 pi over 6. This is 7 pi over 6. 45 degrees, I got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4. This is 5 pi over 4. And this is 60 degrees, so it's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. (270) is pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. So at 300, it's just off the vertical. So it's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. This is 5 pi over 3. The 45-degree angle is going to be, that's 5 pi over 4, 6 pi over 4. This is 7 pi over 4. Because the last one will be 8 pi over 4. 360 is 2 pi. So 2 pi minus pi over 6 is 11 pi over 6. I have to do 7 pi over 6, 8 pi over 6, 9, 10, 11 pi over 6. So that's how we convert to our angles. All right, here's some more example questions. Find these values. A, cosine of 210. B, sine of -60. C, tangent of 5 pi over 3. And D, cosine of 8 pi over 3. So cosine of 210, is it gonna be positive or negative? Why? And it's on which quadrant? Third quadrant, yes. So since this is in third quadrant, we know the answer is gonna be negative. So 210 cosine is square root of 3/3. Or square root of 3/2 or square root of 3? Square root of 3/2. Sine of negative 60. Is it gonna be positive or negative? Remember, negative 60 goes down clockwise. Is the sine X or Y axis? So is it positive or negative? Negative, which is in the fourth quadrant. So we go down 60 degrees. So 360 minus 60 gives us a 300. So the sign is going to be negative radical 3/2. Let's do cosine before we do the tangent one. Cosine of 8 pi/3. Don't use your calculator. Everything you need is in front of you. Oh, on this part here? No, that's what I'm saying. You don't need that. Everything we need is right on the table in front of us. Let's look at what is 8 pi/3? Since let's look at 8/3. Let's turn that into a mixed number. How many times does 3 go into 8? Twice, with how much left over? 2. So what this means, it goes around to 2 pi, because 8 pi/3 becomes 2 pi and 2/3 pi. 2 pi is a complete circle, so we don't have to worry about it. So we just have to go to 2/3 pi. Where is 2/3 pi? We want the cosine of it. 2/3 pi is in the second quadrant at 120 degrees. So the answer is negative 1/2. Everything we have to do for right now for all these, if it's on that chart, it's algebraically manipulated. Because this goes around twice, so that's 2 pi. We don't need that. We just have 2/3 pi. How about tangent of 5 pi/3? Where is 5 pi/3? At what angle? Yeah, 5 pi/3 is 300 degrees. So we have the sine over cosine, which becomes negative radical 3/2 divided by 1/2. Take the top fraction, leave it alone, and flip the bottom. So we're left with negative radical 3. You don't need a calculator. Just have to try to beat it out of y'all. Make sense? Let me see find another example. Boring. That one's boring. Oh, let's look at these. Okay. Example 9. A is the cosine of 5 pi/4. B is the tangent of 315 degrees. C is the sine of 135 degrees. D sine of negative pi over 4, and E cosine 11 pi over 4. I'll look for the next one also, of course. And next time I'll give you all the trig tables and everything that you need, that you already have, but I'll give you one with everything on it. It's also gonna have the double angles, the half angles and everything. So I'll give you the cheat sheets for it. So what's the first one gonna be? 5 pi over 4. What quadrant is that one in? Third quadrant, 5 pi over 4. The cosine is what? Yep, negative radical 2 over 2. This is in the third quadrant. So there's 5 pi over 4. What if you didn't have? What if I asked you what is the degree of 5 pi over 4? How would you do that? Since pi equals 180, we would have 5 times 180 divided by 4. That would be 5 pi over 4. 4 goes into 180 how many times? Well, let's do it slowly. 2 goes in there 90 times. And 2 goes in there 45 times. So 5 times 45 is 225 degrees. So basically, that's all you need to know is to convert from the pi measurements to degrees. Just substitute the 180. Tangent of 315. Three 15 is going to be in which quadrant? Quadrant 4. So is the answer going to be positive or negative? Why? Because if we're in fourth quadrant, no, in the fourth quadrant, we have positives and negatives. So it's negative, it's we sine over cosine. So it's negative divided by positive. Answer would be negative. So radical 2 over 2, radical 2 over 2 makes it a negative 1. Sine of 135. 135 puts us in quadrant 2. Yeah, because it's less than 180, greater than 90. So since sine is going to be positive in the second quadrant, 135 is radical 2 over 2. D, sine of negative pi over 4. What quadrant is that going to put us in? Which one? 4. Quadrant 4, because we start off at 0 and go we're going to go clockwise now. So we're going down pi over 4. Pi over 4 is the same thing as what? 45 degrees. So we go south 45 degrees, which puts that 315. So it's negative radical 2 over 2. And E, again, we have an improper fraction. So what is 11 over 4? How many times is 4 going to 11? 2 times with 3 left over. So it becomes 2 pi plus 3 pi over 4. So this one is a complete circle. We don't have to worry about it. 3 pi over 4. Where is 3 pi over 4? In quadrant 2. And it's looking for cosine, which makes it the negative value in the second quadrant. So far, so good? Okay, those are dealing with angles and degrees and everything else we're looking at. But what if I gave you this? This would be the last thing we talk about today. A point a point negative 3,4 is on the unit circle. I should put quotes around the unit circle, but it's not really a unit circle. Find the values of the 6 trigonometric functions. So we have a circle. We have a point at negative 3, positive 4. We have to first find the radius. So we have, which is the same thing as x squared plus y squared equals the radius squared. So we have negative 3 squared, 4 squared, 9 plus 16, 25, and square root. So the radius is 5. So far, so good? So we have our triangle. This is negative 3, this is 4, and this is 5. And since we're doing from the radius, from the origin, that's the angle in question. Oop, TOA. So the sine of our angle is opposite, which is 4, over the hypotenuse. Cosine of our angle is the adjacent, which is -3, over the hypotenuse. Tangent is the opposite, which is 4, over the adjacent, which makes it -4/3. Secant is 1 over cosine, which is 1 over a over h, which makes it h over a, which makes it 5 over -3, which makes it -5/3. Cosecant is 1 over sine, which is 1 over opposite over hypotenuse, which makes it opposite, hypotenuse over opposite, 5 over 4. And cotangent is simply the reciprocal of tangent. It's going to be -3 over 4. Pretty easy. Once you get the numbers, yeah, it's just plug and play. Pretty much secant is just a flip of the cosine. Cosecant is a flip of sine. Cotangent is a flip of tangent. All right, so even though we don't have any degrees, anything given there, we know what the numbers are. We can figure those out. Any questions?